Hello friends, welcome to the channel. So today we are going to cover geometry, which is very important part of preparing for the CAT examination or any other MB entrance exam, because every year we have observed that at least 3 to 4 questions will generally come from geometry, and mostly they come from triangles. And in triangles also you need not do everything. There are certain topics which have like 95% chance to come. So you need to focus on them, and they are pretty simpler topics. So before starting triangles, to clear your base, what I would first bit do a revision, a brush up of what the parallel lines are and what kind of angles and what kind of knowledge about angles is asked in the questions. So what are the parallel lines? Generally, two lines like this are known as parallel lines. Let it be here or here up to infinity. The distance between those lines is going to be constant or same. And if you draw a line like this is known as a transversal. This is known as a transversal. Okay. And these angles 1 2, these angles are same. 1 is equal to 2. See, there are different terminologies. There are terminologies like corresponding angles, interior angles, or exterior angles, or there may be alternate interior angles. Okay, there may be different kind of terminologies, but you did not need to remember them. You are not going to give a theory exam. Just remember the concept. If two parallel lines are there, then these angles are going to be same. Similarly, this angle is going to be this angle. Okay, so 1 is equal to 2 and 3 is equal to 4, and this, let us say 5. So 5 is equal to 2. This angle is going to be this. Okay, and the sum of these angles, interior angles, 1 plus 2, these will be complementary angles. Their sum will be 90 degrees. No, sorry, their sum will be 180 degrees. These will be supplementary angles. So basic things are asked generally. While we are practicing the questions, you will get to know the idea. You need not learn the terminologies what are used, or you need not just mug up those terminologies. Just remember, this is a basic concept. Like parallel line is drawn by symmetry also. These angles are equal, or this angle is equal. So two lines are like this. These angles are equal and these angles are equal. Okay, and the sum of these angles, this is going to be 180 degrees. Okay, this is going to be equal to this, and similarly you can find out a lot more combinations are there. So generally these kind of questions are asked. Another important thing to remember in parallel lines is that the concept of complementary angles. Complementary angles are if angle A plus angle B is equal to 90 degree, then A and B are complementary to each other. And if A plus B is equal to 180 degree, then A and B are supplementary to each other. Okay, so just remember this. And if line is there like this, so this angle plus this angle, this whole sum is going to be 180 degree. Just basic concept. Okay, so let's move ahead to the next topic, starting the triangles. Basics of angles in a triangle. Let us clear a bit of concept for you. This is a triangle ABC. So this is angle A, this is angle B, this is angle C. So angle A plus angle B plus angle C is going to be 180 degrees. Okay, sum of all the interior angles of a triangle is 180 degrees. And this angle is A dash, this angle is C dash, and this angle is B dash. So A dash plus B dash plus C dash, this is going to be 360 degrees. The sum of exterior angles of any closed entity like triangle or a square or any circle. In circle you cannot define it, or in rectangle, the sum of exterior angles is always going to be 360 degrees. Just remember that. Okay, and another thing is that if these angles are equal, then this is a equilateral triangle. So this is going to be 60 degree, 60 degree, and 60 degree. Okay, so let's move ahead to clear more of your concepts. Also, consider a triangle like this. If two of its angles are equal, then it is known as a isosceles triangle. Okay, isosceles triangle. Also, another property of isosceles triangle is what is being tested in the exam. If these two sides are equal, so these angles are going to be equal. So if two sides are equal, that is known as an isosceles triangle. Then two angles are also going to be equal. Okay, remember this. Another thing is a right angle triangle. If one angle is 90-degree, it is known as a right angle triangle. Also in triangles, properties of triangle, you have to remember that. Let me clear a bit of the area. Another trick, you always remember that. Let us say it is a triangle A, B, C. This is side A, this is side B, this is side C. Sum of two sides is always greater than the sum of third side. Sorry, sum of two sides is always greater than the third side, whatever be the side. Then only a triangle can be formed, otherwise a triangle cannot be formed. In an equilateral triangle, A is equal to B is equal to C. All the three sides are equal. Okay. And another important thing is, I told you in equilateral triangle, all the angles are 60 degrees, 60, 60, 60. Okay. One more thing to remember is an important theorem, Pythagoras theorem. Everyone must be knowing, see, A, B, C, this is a right angle triangle. Let us say this is side A, this is side C, this is side B. Everyone must be knowing that C square is equal to A square plus B square. Okay, this is the Pythagoras theorem. But very important part and very important short trick which you can use in the CAT exam is 3, 4, 5 triplet. This is a very famous Pythagorean triplet, 3, 4, 5. So if this is 3, this is 4, then hypotenuse is going to be 5. If this is multiple of 3, this is 6. So 3 into 2 is 6. So 4 into 2 will be 8. So 5 into 2 will be 10. So 6 and 6 and 8 and 10. This is also going to be a Pythagorean triplet, and this is also going to be a right angle triangle. It need not be integer. It can be 3 into 1.2, 4 into 1.2 and 5 into 1.2. This is also going to be a right angle triangle with sides at, this is equal to 3 to 6, 3, 1, 3. So this will be 3.6 and 4 to 8. This is going to be 4.8 and hypotenuse is going to be the longest side. So 5 to 10, 6. This is going to be 6. Always remember this Pythagorean triplet 3, 4, 5. Okay, this is going to help you in a lot of questions. I will teach you in the questions also. So let's move ahead. Okay, let's solve a bit of questions for now and then we will proceed for a new concept. Okay, find the angle such that the supplement of it is 4 times than its complement. So I told you what is supplement. If a supplement is, if a plus b is equal to 180-degree, then it is supplement. So let us say the angle is x. What is the supplement of it? Supplement of it is 180 minus x. Supplement of it is 4 times, is equal to 4 times its complement. So complement of x will be 90 minus x. So 180 minus x is equal to 360 minus 4x. So this is going to be 3x is equal to 180. So x is equal to 60 degrees. Okay. So this is how, see, the thing is, geometry is a pretty vast topic. So it is not always that every time a hard question will come. Very simple, easy topic can also come, like this kind of question. But if you do not know the terms, if you do not know what is supplement, what is complement, what is orthocenter, I will teach you in this video itself what is orthocenter, what is centroid, these kind of terminologies. If you don't know, you will miss the simple topics also, simple questions also, and these questions will take hardly 20 to 30 seconds of your time, not much of your time. So let's see the next question. Okay, if two complementary angles are in the ratio 1:4, okay, find the supplement of the larger angle. Let us say A plus B is equal to 90-degree. These are complementary and they are in the ratio 1:4. So angle is x plus 4x is equal to 90. That implies 5x is equal to 90. That implies x is equal to 5, 8, 40. Okay, 18 degree. Find the supplement of the larger angle. So larger angle will be 4x. So 4 into 18 and plus angle y is equal to 180. So y will be the supplement of it. So y is equal to 180 minus 4 into 18, so minus 72. So 180 minus 72, 8 and 10, 108. So answer will be 108 degrees. Okay. Okay. And also while practicing, when you are practicing for the CAT exam, try to solve in your notebook by taking very less of your space, because generally the notebook size will be very small. It will not be like long sheet of paper. The notebook size will be the length of this palm only, not much. And it is very hard to go to the next page, look at the back page. And another thing is, only one time single very thin notebook is given. It will not be repeated if you have used all the pages. So try to practice while taking less, consuming less of the space at your home. Then only in exam also you will take less space. Okay, this is a pretty important factor for CAT exam. In a parallelogram ABCD, angle A is equal to 70 degrees. So let us say a parallelogram is there. So ABCD, and angle A is 70 degrees. In parallelogram, this angle will be equal to this angle. So this is also 70 degrees. And this angle is x, this angle is also x. So 2x plus 70 plus 70 is equal to 360. Sum of all the angles in parallelogram is 360. What is the sum of the angles B and D? Okay, okay, A, B, C, D. And okay, sorry, so this guy has taken the angles like this. Parallelogram, you can say A and B and C and D. Okay, this is 70, this is 70, this is x, this is x. So 70 plus 70 plus 2x is equal to 360. We have to find B plus D. So 2x we have to find. 2x is equal to 360 minus 140 is equal to 0 to 220 degrees. Okay, 220 is the right answer. Now let's see question number 4. In a triangle DEF, so okay, point A, B, C are taken on DE, DF. Okay, so let me draw a bigger diagram to clear a doubt. To solve this question, let me draw a bigger diagram. So A, D, E, C, B and F. We have to find ACB. We have to find ACB. We have to find this angle. Okay. See, BC is equal to CF. So this is X, this is X. Okay. And AC is equal to EC. So also it is given that angle D equals 40 degrees. So this is 40. Okay. And this is X. So angle E will be 40 plus E plus X is equal to 180. So E is going to be 140 minus X. So this is 140 minus X. And AC is equal to EC. I told you in isosceles triangle, two sides are equal, then both the angles are going to be equal. So this is also going to be 140 minus X. Okay. And this is 140 minus X. So angle C will be 140 minus X plus 140 minus X plus C is equal to 180. So C is equal to 180 minus 2 into 140, 248, 212 plus 2x is equal to 2x minus, so 280 minus 180 is equal to 100. So C is 2x minus 100. Okay. Also, this whole is equal to 180 degree. So 2x minus 100 plus what angle we have to find? We have to find ACB plus angle ACB and plus this angle. This angle is going to be, from this triangle we can find out angle C. Let us say this angle is C dash. So C dash plus 2x is equal to 180. So C dash is equal to 180 minus 2x. So plus 180 minus 2x is equal to 180 degree. So 180 180 gets cancelled and 2x gets cancelled. So angle ACB is equal to 100 this side. This is equal to 100 degrees. So 100 degrees is the right answer. See, this like this you have to play in geometry with triangles. If you know the basics, and very simple basics you need to know, and you can solve the question. So let's move to the next topic. We are starting now from the triangles specifically. We are going to learn a bit more. So let's start. Okay. So in triangles, I already told you this kind of figure is known as a triangle. ABC, angle A plus B plus C is equal to 180 degree. One important term you have to remember is, see, what is the perimeter of a triangle? Let us say this side is A, this is B, this is C. Perimeter is equal to A plus B plus C. There is a very important term known as semi-perimeter, S. This term is going to be used in a lot of formulas. So remember it. S is equal to A plus B plus C by 2, perimeter by 2. This is a very important term. And this term can be used even to find out the area of the triangle. So area of the triangle can be written as S into S minus A into S minus B into S minus C. Okay, this formula is also used a lot many times, and in the coming slides we are going to learn in center will be area upon semi-perimeter. I will teach you how to solve those questions also in triangles. Remember that the sum of two sides is greater than the third side, so B plus C will also be greater than A similarly. Okay, and there are different types of triangles. Acute angle, if all the angles are less than 90 degree, that will be acute angle triangle. One is right angle triangle if one angle is 90 degree, and one is going to be obtuse angle triangle if any angle is greater than 90 degrees. This will be known as obtuse angle triangle. This is right angle triangle, and first one is acute angle triangle. If all the sides are equal, then it is a equilateral triangle. A area of equilateral triangle is given as root 3 by 4 A square. Remember this. Altitude of equilateral triangle is given as root 3 by 2A. Okay, so these are the basics. Let's see what I have prepared for you. Before going to the centroid, I will also teach you. See, area of a triangle is given as half into base into height. So if this is a triangle, this is the altitude, so this is going to be base and this is going to be height. Okay, so half into base into height. Height does not need to be within the triangle, it can be outside the triangle also. Consider this triangle, so this can be height and this can be base. So area is equal to half into base into height. Okay, another thing for area of triangle is, I told you area can be found out by semi-perimeter formula. Okay, and for finding area, another very important formula is there. Let us say a triangle is there, so this is side A, this is side B, this is side C, this angle is theta. So area will be given as half into A into B into the angle between those two sides, sine of angle between those two sides. This is also a very important formula. All of these I am teaching you very less in triangles. I am not covering everything because 95 to 98% of the questions will come from these topics only. You need not to cover everything from 6th class to 10th or 12th class. Okay, that is going to take a lot, consume a lot of your mind. So remember these basic formulas, these will be very helpful. Okay, so now let us understand what are centroids. Consider a triangle. This is a very important topic. A, B, C. Draw median like this. median means it will divide this into two equal parts. Draw median from B, so this is equal to this. Draw median from C, so this will be equal to this. Okay, this center is known as G or centroid. Okay, centroid divides this median AD into ratio 2:1. So this is 2k, this is 1k. Okay, remember this. And also, if there is a line C, G, O, G and C, this is orthocenter, this is centroid, and this is circumcenter. This will also be divided in the ratio 2:1. Okay, centroid always lie inside the triangle, whether it be acute angle triangle, whether it be obtuse angle triangle, or whether it be right angle triangle. Every time centroid will be inside the triangle. Centroid is the centermost point of the triangle. Okay, now let's see what is a circumcenter. So A, B and C. We draw a perpendicular bisector to this, which bisects this, and it is perpendicular. Similarly, perpendicular bisector like this of AC, perpendicular bisector of AB like this. This point is known as circumcenter. Okay, for acute angle triangle, circumcenter is inside. For right angle triangle, circumcenter, and also important category part of circumcenter is that if you take this as origin and you draw like this, so the circle drawn with this radius, okay, or this radius from the circumcenter is going to touch all the vertices of the triangle. That's why it is known as the circumcenter. It is circumscribing the triangle. In case of right angle triangle ABC, circumcenter is midpoint of hypotenuse. So this is circumcenter. Okay, so it is going to be like this. In case of obtuse angle triangle, circumcenter will be outside the triangle. For example, like this. Draw a perpendicular bisector is going to be like this. For this perpendicular bisector is going to be like this. Sorry, it is going to be like this. For this, a perpendicular bisector will be going to be like this. So they are going to meet somewhere here. Okay, so circumcenter need not be every time inside the triangle, but remember what is a circumcenter. Circumcenter is like the point of all the perpendicular bisectors, and it circumscribes the whole triangle, and it is represented by R. The radius, the circum radius is represented by R, and it is given by the formula ABC by 4 into A. A, B and C are the sides. A is the area of the triangle. Okay, this formula is also frequently used. In case of right angle triangle, area is given as R into R plus 2R, where R is in center and this R is circumcenter, circumradius. This is in radius, sorry, not in center, in radius. Okay, so let's see in center. Triangle is there. Draw the angular bisector. This angle is equal to this angle. This angle is going to be this angle. This is going to be the in center, and from in center, the radius of the in center or in radius is the radius with which the largest circle can be drawn within the triangle. Okay, that is why it is known as in center. It is represented by R. In center is calculated as area by semi-perimeter. This formula, semi-perimeter, is A plus B plus C by 2. area you can calculate by lot many things, half into base into height, or a into b into sine theta, or s root of s into s minus a into s minus b into s minus c. You can use a lot of formulas. You have to play by the conditions whatever are given in the question. Okay, this is the in center. Another important thing is orthocenter. Draw altitude like this, draw altitude like this from the vertices, draw altitude like this, and sorry, take a triangle, draw altitude, draw altitude, and draw altitude. Okay, altitude is 90 degrees. This will be known as orthocenter. Okay, this is the orthocenter of the altitudes. The intersection of the altitude is known as the orthocenter. For a acute angle triangle, orthocenter is going to be inside. For a right angle triangle, this vertex point is the orthocenter. For a obtuse angle triangle, orthocenter is going to be outside. Another thing to remember is OGC. So this is orthocenter, this is centroid, this is circumcenter, and 2:1 ratio. This is also divided like this. Okay, remember this. Another important thing I think I forgot to tell you is one extra formula for centroid is there. If this is x1 y1, this is x2 y2, this is x3 y3. So cx will be given as x1 plus x2 plus x3 by 3, and cy will be given as y1 plus y2 plus y3 by 3. This formula is also certain times used. Okay, and in case of triangles, one area formula is also there, plus minus half determinant formula, x1 x2 y1 y2 and x1, sorry, I think it is not like x1 y1 x2 y2 x3 y3 and 1 1 1. Okay, this is the determinant formula. This is also used. Okay, determinant I think you must be knowing. This can be calculated as half, and x1 you draw like this, so y2 minus y3, and plus then you draw like this, plus y1, then this into this, so x2 minus x3, and plus 1, so you draw like this, so x2 y3 and minus x3 y2, like this. Determine this is not used that much, used randomly, but for the sake of knowledge I am teaching you this. Sometimes it may be asked in the options also, which of the following option is the formula of the area. In exact exam these kind of questions are asked. Okay, so let's see important theorems also. Pythagoras theorem I already told you, it is used for right angle triangle ABC. ABC, C square is equal to A square plus B square. Another thing is 3 4 5 triplet. Always remember 3 4 5 triplet. This is going to make life very easy for you. It is used in many concepts, in many questions of the CAT exam. Another theorem is midpoint theorem. So A, B, C, draw D like this, D, E. D is the midpoint of AB, so this is equal to D. E is the midpoint of AC, then DE is going to be parallel to BC. This is the midpoint, or vice versa. Okay, not exactly vice versa. The thing is, let us say a triangle is there, you draw a particular parallel line like this. Okay, so A, B, C, D and E. If this is ratio A, in this, if DE is parallel to BC, then AD upon AB is going to be equal to AE upon AC. Okay, this is known as proportionality theorem. This is also used in a lot many questions. So midpoint theorem and proportionality theorem. Midpoint theorem is a part specific case of the proportionality theorem. This is the proportionality theorem. Remember these three theorems, and don't worry, we are going to learn them from the questions also. We are going to practice a lot of questions in future videos also, in today's videos also. But for the sake of knowledge, just to clear your concept, I am teaching you these. Okay, let's see. Yeah, area of triangles, I think we have already learned. Area is equal to half into base into height. Area is equal to product of two sides and the angle sine into half into product of two sides into sine of angle between them. And another formula for area is the determinant formula, where the coordinates are given. Another formula for area is in radius is equal to area upon semi perimeter. From this also you can find out the area, but this formula is generally used to find the in radius. Another formula is r is equal to circumradius is equal to abc upon 4 into area. This formula is also used to calculate generally the circumradius. For in case of right angle triangle, area is equal to r into r plus 2r. See, I have mucked up a lot of formulas for geometry because they make your life very easy in competitive exams, and they give you a competitive advantage over the other students and save a lot of your time. So I think it is time to do the practice the question series. So let's start with the questions. In questions also, I am going to clear a bit concepts for you. A triangle is drawn on a clock face. So a clock is there. Okay. So this is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And triangle is drawn with connecting 11 and 1 and 6. Okay, we have to find out the angles of the triangle. So let us say this is the centermost point of the circle. Okay, so this is the radius of the circle or of the clock. This is also the radius of the circle or clock. And you know, if you check this angle theta, a clock has whole angle is 360 degrees, and it is divided into 12 equal parts. So 360 by 12, each sector will give you 30 degrees. So this is 30 degrees, and this is radius, this is radius. So this line is equal to this line. So this is an isosceles triangle. In case of isosceles triangle, let us say this angle is x, so this angle is also going to be x. Because of this sector condition, this 30 degree, this between 12 to 1, the angle is 30 degrees. So between 11 to 12, the angle will also be 30 degrees. In triangle ABC, x plus 30 plus 30 is equal to 180 degrees. So 2x is equal to 180 minus 60, so 120. So x is equal to 60 degrees. So this is 60, this is 60. Okay. In a circle, there is another theorem also. From the center, if a chord is there, okay, if this angle is theta, from these 2 points, go to any other point, go to this point or go to this point or go to this point. These angles will going to be theta by 2. This is a theorem, this is a proved theorem, so you can remember this as a sector theorem or anything what you like. I generally do not focus on the names. So this is 60 degree. So this angle is going to be, because this is from these 2 points only, A and B, and 60 degrees formed at the center. So from A and B, you go to any other point, you go to 8 also, or you go to any other point, you will get 30 degree. So this is 30 degree. Let us say this angle is y. This angle by symmetry, this is also y. So in triangle A, B and D, 60 plus y, this angle, plus 60 plus y this angle plus 30 this angle is equal to 180 degree. So 2y plus 60 60 120 150 150 is equal to 180 degree. So 2y is equal to 180 minus 150 is equal to 30 degree. So y is equal to 15 degree. So what are the angles of this whole triangle formed by 11, 12 and 6? This angle 60 plus 15 75, and this angle 60 plus 15 75, and what is asked in the what are the angles of the triangle 11 6, and this is going to be 30 degrees 30 degrees. So these are the angles of the triangle. Let's move ahead to the next question. Okay, so question number 2. Suppose xyz is a triangle. Xyz is the midpoint of xy, b is the midpoint of xz. So this is equal to this is equal to this. And what is the ratio of the area of triangle xyz to xaz? Okay, so we have to find out the area of this xaz, and this is b, sorry. So xab and xyz. Okay, so by proportionality theorem you can use a lot of concepts. Let me think, what concept can I use in this? Okay, so draw a altitude like this, xd or p. This is 90 degree, this is 90 degree. Now by proportionality theorem, this line is parallel to this line, and this is dividing in two equal parts. Okay, this is the by midpoint theorem. So there is a property in this kind of case, the AB, since it is now parallel, and it is dividing these in the ratio 1 is to 1, this in the ratio 1 is to 1. So all the lengths or everything of this triangle is going to be divided in the same ratio. So altitude xp by pd, xp by pd, this is also going to be 1 is to 1. Okay, or xp by xd, this is going to be 1 by 2. xa by xy, this is 1 by 2 because this is the midpoint. Okay, xb by xz, this is be 1 by 2. Also ab and yz, this is also going to be in the same ratio, so 1 by 2. So area of xyz divided by area of xab is equal to half into xyz, what is the base, yz, into height is xd, divided by half into xab base into xp, half gets cancelled. So yz by ab is equal to 2 by 1 into xd by xp from this. Okay, so no, from this xd by xp, this is also going to be 2 by 1, so 4 is to 1 is the right answer. Okay, so always remember, if a parallel line is dividing in the ratio 1 is to 1, or this by this whole is 1 by 2, so every other length will be divided into same ratio, whether it be altitude or whether it be this base. Okay, and area will be divided in ratio of, if the ratio of sides is 1 m by n. Okay, so area will be m by n square. Like this you have to use. Let's move ahead to the next question. Okay, according to the given figure, if BE is the median, so let me draw a bigger figure. So A, B, C and D. BE is the median, so this is equal to this, This is 8, this is 6. So I told you 3 4 5 triplet. So this is 3 into 2, this is 4 into 2, so this will definitely be 5 into 2. So this whole length is going to be 10. Let A be x and EC be x. Okay, this is D, and area of the triangle can be given as area of triangle ABC. Area is equal to half into base this into height. This can also be written as half into base can be taken as AC, so into 10 into height can be taken as BD into BD. So half gets cancelled. So BD is equal to 6 into 8 by 10. It is 4.8. Okay, PD is 4.8, and we have to find DE. We have to find DE. So BD is 4.8, and we have to find X. So can in X we use 3 4 5 triplet. So yeah, 5 into 1.2 is equal to 6, and 4 into 1.2 is equal to 8. So X will be going to be 3 into 1.2. So X is 3.6. So DE is equal to, no, not sorry, not X, this DC. DC is 3 into 1.2, this length. X is this whole, this is whole. Okay, so D is going to be X minus DC, and since E is the midpoint of AC, so X is going to be 5. So D is equal to 5 minus 3.6 is equal to 1.4. This is the right answer. D is 1.4. Okay, so here 3 4 5 triplet helped me a lot. Otherwise I will have to use the Pythagoras theorem every time I have to do c square is equal to a square plus b square. It is going to take a lot of time. So let's move it to the next question. Okay, find the coordinates of centroid and circumcenter. Okay, a triangle is there. What are the vertices? Let me draw this. Vertices are 0 0, and vertices are 10 0, and vertices are 0 10. Okay, this triangle is there. We have to find out the coordinates of centroid and circumcenter. For a right angle triangle, centroid is going to be in the middle, and for finding out centroid, Cx is equal to x1 plus x2 plus x3 by 3. So 0 x1 plus x2 plus 10 plus x3 by 3 is equal to 10 by 3. Cy is equal to y1 plus y2 plus y3 by 3 is equal to 10 by 3. So for centroid, the coordinates will be 10 by 3 and 10 by 3. Okay, and we have to find out the circumcenter. For circumcenter, actually, in case of right angle triangle, the circumcenter is the midpoint of hypotenuse. Okay, we know that, and this we have to calculate. So okay, so this is the midpoint of this whole line. So this coordinate will be 5 5 based on my experience. Otherwise you can calculate also. This divides in the ratio 1 is to 1. So you can use the section formula. So circumcenter x will going to be 1 into 10, 1 into 10 plus 1 into 0, 1 into 0 divided by 1 plus 1 is equal to 10 by 2 is equal to 5. Circumcenter y is equal to 1 into 0, 1 into 0 plus 1 into 10, 1 into 10 divided by 1 plus 1 is equal to 10 by 2 is equal to 5. So 5 5. Okay, so let's move ahead to the next question. Question number 5th. What is the angle B in the given figure? Okay, this is equal to this, so x x, this is equal to this. Okay, before that, what is this angle? This is 180 minus x minus 96 is equal to 84 minus x. So this is 84 minus x. And what is this angle? This is 180 minus 2x. What is this angle? You calculate also, you will get 2x. Otherwise, in a triangle, you can directly say theta is equal to a plus b. Exterior angle is equal to the sum of the interior opposite interior angles. So this is 2x. What is this angle? Let it be theta. So 84 minus x plus 2x plus theta is equal to 180, or theta is equal to 84 plus x. So theta is equal to 180 and minus 84 minus x is equal to 96 minus x. We have to find out angle B. Okay, so wait, let me think. This is 2x and this is x, this is x, this is 2x. So theta is equal to 2x. Okay, so theta is equal to this, so 2x is equal to 96 minus x, because see, this is equal to this, so this is 2x, so this is 2x. So 2x is equal to, so 3x is equal to 96. That implies x is equal to 96 by 3, 339, 326. And we have to find out theta. So theta is equal to 2x is equal to 2 into 32, 43, 64 degree. This is answer, 64 degree. Okay, let's move on to the next question. Question number 6. What is the distance between orthocenter and one of the vertices of an equilateral triangle? Okay, equilateral triangle is there, so 100, 100 and 100, and orthocenter is this. We know that orthocenter divides, okay, orthocenter is this, and one of the vertices of an equilateral triangle. Okay, so we have to find like this. Okay, 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 this is also center, and this is the sum of altitudes. So always remember that in an equilateral triangle, in this is also, while solving the questions, we are going to teach you this. In equilateral triangle, orthocenter and centroid, they are at the same point. You can do this, solve this by using theorems and proving, but just remember this important concept. So this is orthocenter, C, this is equal to G, and we know that centroid divides this altitude in the ratio 2 is to 1, or median also. So in case of a equilateral triangle, median and altitude are same. So A, B, C, also this is D. We know that in case of equilateral triangle, AD or altitude or median is given as root 3 by 2 into length. So 50 is equal to 50 root 3. So let us say this is K, this is K, 2K and 1K. So 3K is equal to 50 root 3. K is equal to 50 root 3 by 3. And we want to find out the distance between any one of the vertices and the orthocenter. So this is 2K. That implies 2K is equal to 2 into 50 into 3 root 3 by 3. So this is 100 by root 3. This is the right answer. Okay, let's see the next question. This is also very important and very good question. So let's solve this. Two circles are drawn in an equilateral triangle as shown in the figure. Find out the ratio of the radius of the, okay, this, first of all, this is an equilateral triangle. If you draw a line like this is going to be tangent to both the circles, and any line which is tangent. Okay, and if you take from center, if you draw like this radius r1 or draw like this radius r2, this is going to be 90 degree, this is going to be 90 degrees, because any circle is there, a tangent is there, and from radius you take line like this is going to be perpendicular. This is going to be r2, and since this bigger circle is the in center of the whole circle, okay, and this r1 smaller circle is the in center of the smaller triangle ABCDE, okay, and we know that this is also equilateral, okay, so this is r1 and this is r1, and we know that this DE 90 degree 90 degree, okay, so this DE is actually parallel to BC. DE is parallel to BC. So by proportionality theorem, we know that AD by AB will going to be equal to AE by AC, and other entities or other lengths are also going to be in the same ratio, is equal to DE by BC, or this height H1 is equal to H1 by whole height H2, or in the same ratio is for the in centers R1 and R2, okay. We have to find the ratio of the radius of this smaller to larger, or the ratio of in centers. If we are able to find out H1 by H2, then it is going to be very easy. So H1 is equal to AP whole altitude. H1 is H2 minus 2R2, okay, and divided by H2, so divided by H2. Also H2 is whole height. In case of equilateral triangle, it is going to be root 3 by 2 into A, into length, let it be A, and R2 in center, we know that R2 is given by area by semi perimeter. Area of equilateral triangle is root 3 by 4 A square. Semi perimeter is A plus A by 2, so 3A by 2 divided by 3A by 2. So root 3 by 4 A square divided by 3A divided by 2, 2 to 4 AA, so A by 2 root 3. This is R2, and H2 is root 3A. So H1 by H2 is this H2 minus 2R2. So H2 minus 2R2 is equal to, what is H2? Root 3 by 2A minus 2R2, 2 into A by 2 root 3. This is given as 2 root 3 common, so 3A minus 2A is equal to A by 2 root 3. And what is H2? H2 is root 3 by 2A. So H1 by H2 is equal to this value. This value is this A by 2 root 3 divided by H2. H2 is this root 3 by 2A. So A gets cancelled, 2 gets cancelled. So 1 upon root 3 into root 3 is equal to 1 by 3. This is the ratio 1:3 of the radius or in centers. This is a very good question, and it clears a lot of concepts about proportionality theorem also. So and in centers also. Let's see a few more questions and then we can wind up for today. In a triangle ABC, the length of side A, B and C. Okay, A, B and C. AB is 17.5 and AC is 9. Let D be a point on the line segment BC such that AD is perpendicular. So this is 90 degree AD. If AD is equal to 3 centimeter, AD is equal to 3. What is the radius of the circle circumscribing the triangle ABC? So we have to find out the incenter like this. We have to find out incenter. So this is 3, this is 9. So can we calculate this DC? Yeah, DC can be calculated. DC is equal to root under 81 minus, or another thing we can do. See, in center, sorry, we do not have to find out in center. We have to find out circumcenter. Let me clear few things. We have to find out circumcenter because it is given that some circumscribing the triangle ABC. So we have to find out this. Big R we have to find out. Big R can be given as A B C divided by 4 times area. Okay. And is equal to A B C divided by, let, is equal to 17.5 into 9 into BC divided by 4 into half into what is base BC into height 3. So BC get cancelled, 2 to 4. It is given by 17.5 into 339 into 3 divided by 2. If you are going to find out, it is going to be 3, 5, 15, and see 21, 22, 3, 3, 4, 5, 52.5 by 2. It is given by 2 to 4.25. 26.25 is the right answer. Okay. So let's see another question. If the coordinates of the orthocenter and centroid of the triangle are, okay, then the circle. Okay, we know that OGC, this is minus 5, 7, and orthocenter and centroid, this is 5, 5. We have to find circumcenter XY, and we know that this is divided in ratio 2:1. So by section formula we can write as 2 into x plus 1 into minus 5 divided by 2 plus 1 is equal to x. So 2x minus 5 divided by 3 is equal to, not x, sorry, is equal to 5, is equal to 5. That implies 2x is equal to 15 plus 5, 20. So x is equal to 10. And we can write as 2 into y plus 1 into 7 divided by 2 plus 1, 3 is equal to 5. So 2y is equal to 15 minus 7. So y is equal to 8 by 2 is equal to 4. So coordinates will be 10 and 4. This is the right answer. Okay, one more question and we will be done for today. Okay, consider the right angle triangle ABC as shown in the figure. The triangle is right angled at A. Okay, so this is right angle. It is known as AC is 15, AB is 20. Okay, and AD is the altitude. So this is also right angle. See, this can be written as 3 into 5. This can be written as 4 into 5. So 3, 4, 5 triplet. This can be written as 5 into 5 is equal to 25. So this whole is 25. Okay. Area of the triangle can be given as half into 15 into 20, half into base into height. Right angle is equal to half into AD into 25. So AD can be given as half of gets cancelled, 5, 3, 15, 5, 5, 25, 5, 4, 20, 3, 4, 12. So 12. AD is equal to 12. Now this can be written as 5 into 3. This is 4 into 3. Now this is the hypotenuse for triangle AC and D, and this can be written as 3 into 3 is equal to 9. Similarly, this can be written as 5 into 4. This can be written as 3 into 4. This can be written as 4 into 4 is equal to 16. So 16 plus 9, 25. Okay, now we know all the dimensions. What we have to do is we have to find out the in radius. So in radius 1, or A, D and C, in radius 1 can be given as area by semi perimeter. Area is half into base into height divided by semi perimeter is 15 plus 12 plus 9 divided by 2, given as 2 6. So 9 into 6 divided by 15 and 9 24, so 36 by 2. 15 and 9 36 by 2 18, so 9 to 18, so 3. R1 is 3. R2 in radius 2 is given as area by semi perimeter, so half into base into height divided by semi perimeter is 12 plus 20 plus 16 by 2 is equal to 2 6 12. So 16 into 6 divided by, so this is 20 and 12 22 plus 16 38 by 2, so this is 17. So R1 by R2 is 3 by 16 into 6 into 17, so 3 to 6, so this is 17 by 32. I think, no, wait, I'm doing some mistake here. So half into base into height. Okay, so 12 plus 20 plus 16, so 20 30 40 48 by 2. Okay, 20 30 40 48 by 2, 2 to 4 2 4 8, so divided by 24, 4 4 16, 6 24, so 3 is to 4, 3 is to 4. This is the right answer. Okay, so R1 is to R2 will be 3 is to 4. Okay, so I think we have covered a lot today, and we have covered the concept of orthocenter, centroid, circumcenter, in radius, circumradius. These kind of questions do frequently come in CAT. So I'm going to be coming with next video also, another video dedicated on triangle questions only, not the concept, and after that we can proceed to the further remaining geometry. So let's meet in the next video. Till then, bye bye.